Our course title is Computer Technology. Our course code is CTE431. So decoder. The decoders is an electronic device that is used to convert digital signals to analog signals. So analog signals represent information as continuous waves, and digital signals represent information as discrete values, typically using binary codes, which are 1 and 0s. So it allows single input line and produce multiple output lines. So the decoders are used in many communication projects that are used to communicate between two devices or end users. So the decoder allows n inputs and generate 2 power n numbers of outputs. For example, if we give 2 inputs, that will produce 4 outputs by using 4 by 2 decoder. So we are to look at the terminals. How many input do we have for us to justify the output? So here is the diagram of decoder. So let's take a look of this diagram. Here is the n input, which is the input line. So those terminals are 4. We have 1, 2, 3, 4. 4 input line. Then if we are to look carefully, we are to see that the 3 are at top, then the 1 behind represent the n input lines. So here is the next terminal, which is the output point, which we say that it is specified as 2. So we also have 4 terminals, but in these 4 terminals, the first 2, which those who are connected, will be the one that will provide an output. So let's look at the truth table of decoder. So the encoder and decoders are designed with logic gates such as AND gates. So the input lines, only one can be active at a time. The output will be the binary code, which is high and low. There are different types of decoders like 4 to 8, and the truth tables of decoder depend upon a particular decoder chosen by the users. So the subsequent description is about a 4-bit decoder. So we are to work on 4-bit decoder, and its truth table of the 4-bit decoder allows only 4 outputs, such as A0, A1, A2, and A3, and generates 2 outputs as shown on the diagram. We are going to see the diagram at the next slide. Let's take a look of this decoder circuit. We have the 2 input line, then we now have 4 output lines. As we said earlier, the input lines, only one can be active at a time. The output will be the binary code, right? Since we are to look at those binary code, let's look at our input lines, which is A and B. So they are represented also as a binary code, 1 and 0 for A, for B 0 and 1. We should not consider this first one. So let's look at our output. So what are our output here? So our output represented D0, D1, D2, and D3. So if any of the output is high, then others should be low. So let's look at the A. Our A, then D3 terminal is connected to our AND gate, which is our input devices. So let's look at the first terminal is connected to D3. So as we notice that our D3, our A is active, then our D3 also is high and low. So let's look at B. Our B, which is connected with D0, AND gate, we notice that the first input is low, then the second is high. So let's look at the third one, which is D1. D1 is connected to terminal B, so the other terminal is connected to A. So let's see what do we have on those terminals. A, we are having 0, so B, we are also having 0, so our D1 should be low. So for the B, let's look at the D2 terminal. So our AND gate in D2 is connected to terminal B, which is active A. Then the second terminal is connected to A, which is also active. So our D2 is active. At this point, we are to have one output, which is 1 1. Others are on and off, which is 0 and 1, 0 and 1. So D2 should be our output. Programming language. Programming language is a set of instructions that tells a computer what to do in order to come up with a solution to a particular program. So programs are written using a programming language. So those programs might be code, which represent binary codes, which are 1 and 0. We normally use them to provide an appropriate output with significant function. So we will be able to provide a design of games, images with the help of those programming language. So a programming language is a formal language designed to communicate instructions to the computer. So those programming language provide means and access for us to produce instructions to the computer. Once instruction or commands is given to a computer, definitely computer provide the appropriate output of that particular input given to it, if there is no any mistake. So there are two types of programming languages. We have low-level language and high-level languages. There are two different types of programming language. So low-level language. Low-level languages refers to low because they are very close to how different hardware elements of a computer actually communicate with each other. So regards to this low-level language, they only understand computer language, so it is difficult for individual to understand low-level language, rather the hardware devices. So low-level languages are machine-oriented and require extensive knowledge of a computer hardware. They are very close to the hardware because any data you intended to put on the system which require binaries like 1 and 0s or numbers can be understood by the computer automatically. And the configuration. So there are two categories of low-level languages, like machine language and assembly language. So if we are to provide an examples of those low-level language, the best way is that we should provide machine language and assembly language. They also has their function, but they are under low-level languages. So technically, machine code or machine language uses those two names. So machine language can be represented also as machine code. So it's the only language that is directly understood by the computer and it does not need to be translated. Let's look at this diagram which holds 1 and 0s. So those are the languages that the machine, which is the computer system, understand directly. So whenever you input vital information regards to 1 and 0 or vital data without mistake, they will be able to provide the output for you. Like for instance, in terms of using Notepad, you can use binary numbers to provide different designs, since the hardware only understand 1 and 0s, which are binary codes. So all instructions use binary notation and written as a string of 1 and 0s. So program instructions in machine language may look something like this, as we can see it earlier. Let's look at this diagram on the screen that has 1 0 1 0 1 0 1 0 and so on. So technically speaking, this is the only language computer hardware understands. However, binary notation is very difficult for humans to understand. This is where assembly language comes in. We are now in assembly language. Since we said that the low-level language only understood machine language and assembly language, so the machine language or machine code only understand computer hardware. But in regards to the assembly language, is a step ahead of that machine language due to improve programming structure and make machine language more readable by humans. An assembly language consists of a set of symbols and letters. So symbols and letters are implemented to assembly language in order for the low-level language to be more advanced. So translator is required to translate the assembly language to machine language. This translator program is called the assembler. So assembler is represented as a translator program to the low-level language. It can be called the second generation language since it no longer uses 1 and zeros to write instructions, but terms like move, add, sub, and end, and so on. So as we can see, there is a significant improvement in low-level language with the help of assembly language. So many of the earliest computer programs were written in assembly language. So most programs today don't use assembly languages very often, but they are still used for applications like operating systems of electronic devices and technical applications.